Hello students, and welcome to this lesson on exponential equations. Our objective today is that we will solve exponential equations of the same and different base using journal notes in 7-9 Exponential Equations Practice. So in the past, we've talked a lot about actually taking a logarithm and turning it into an exponent, or an exponent and turning it into a logarithm, because the logarithm and the exponent are inverses of one another. So today we're going to take that idea, right, of the inverse, and that's going to help us solve equations. For instance, if I wanted to solve the equation square root of 2 to the x is equal to 4, how would I solve that? Well, you guys know that we would take the square of both sides, and then you get 2x is equal to 16, and so we can solve that x is equal to 8. So what's interesting about this is that is the process of solving, right? Those are inverses of one another. So this square root and this square work together to cancel each other out. That's why we had to use the square, is because it's the inverse of square root. So likewise, when we go to start solving exponential equations, what we're really doing is we're going to take a logarithm of each side, and that's going to actually give us our answers. All right, so let's talk about if we have the same base. So let's say that we have some equation here, right? And we're just going to do something simple. I'm going to say 2 to the 15 is equal to 2 to the x plus 3. So we have something of the same base. So if I take a logarithm of each side, it's equal to log of 2 to the x plus 3. Well, we know that the log base 2 of 2 is equal to 1. So that'll be very nice for getting rid of my base. And I also know that due to my power rule, right, if I've got something inside here, then it's going to come out to the front. So my exponents are going to come out to the front. So now I'll get something that looks like this. I'll have 15 log base 2 of 2 is equal to x plus 3 times log base 2 of 2. But we know that log base 2 of 2 is just 1. So we have 15 is equal to x plus 3, and then x is equal to 12. So kind of a shortcut that we can see is that if we have something of the same base, right, then we can just set those exponents equal to each other. So if they have the same base, set exponents equal. Interesting. So for different bases, we have to come at it from a different approach. So here we have two numbers that are obviously going to be different, right? So one method that we could use is that we could try and take the log base 5 of each side, and you're going to find that then you would have, so if we take the log base 5 of each side, then what we're going to end up with is 2x is equal to, and then this is hard to evaluate, so we'd have to use a calculator, log base 5 of 15. But additionally, what we can see is that if we've got something like this, then what we might see is that then 2x is equal to, if we're trying to evaluate this in a calculator like we're going to have to, it's going to be log of 15 divided by the log of 5, right, because of our change of base formula. And then you've still got 2x on this other side, so then you'd have to divide both sides by 2, and you get x is equal to log base 15 over 2 times log of 5. So a shortcut here that we can talk about is that if different bases then we can actually say that our x, right, will be equal to the log of the left-hand side divided by the log of the right-hand side. And this one's a little bit less intuitive, so we're going to do a couple of practice problems with it. So let's go ahead and get started. All right, so for the same base, we're not always going to be given them exactly in the same base, but we can intuit that they are the same base. For instance, if I have 16 here, right, I know that 16 is actually 2 to the 4th power to the 3x. And the reason that I chose 2 is because I looked at 16 and I looked at 8 and I said, well, what would be a base of both of those? And so then we see that 8 is going to be 2 to the 3rd. And so we're going to get that we use our power rule here, right? 4 times 3x, so that'll be 2 to the 12x is equal to 2 to the 3. Therefore, x, we'll say that 12x is equal to 3, and you get that x is equal to 1/4, right? Because 3 divided by 12 will give me 1/4. All right, so example 2, this one, again, is a little bit more difficult because I have this 243 number. So I'm going to start with 9, right? And I'm going to say, okay, well, what can I reduce that to? And I can say that's 3 squared to the 3x power. Now, for 243, you can go through the powers of 3 and see which one it is. Personally, what I do is, if I see a number like this and I want to know what power it is, I would say log of 243 divided by the log of 3, right? Because that'll be the logarithm of 243 in base 3. So you can plug that into your calculator, and you'll get that that's 3 to the 5th power. You could also just run through the powers of 3 to kind of figure that out as well. So then this is going to be 3 to the 6x is equal to 3 to the 5th. And again, it's the same base, so I can go ahead and say 6x is equal to 5. And therefore x is equal to 5/6. All right, so those are the same base. Let's look at different bases again. All right, so I've got this weird looking thing, right? I have base 15 here. So the 285 is very unlikely to be in base 15. So I'm going to go ahead and go straight to the different bases route. So what we're going to say is we want to go ahead and take the log base 10 of both sides. All right, so I've got the log base 10 of both sides, and due to my power rule, I know that this 3x is going to come out in front, so I can rewrite this as 3x log 15 is equal to the log of 285. All right, and I want to isolate x now, right? X is being multiplied by log 15 and 3, so I'm going to say that x is equal to log of 285 divided by 3 times the log of 15. And I would go ahead and put this in your calculator and get out an approximate answer. And your approximate answer is that's going to be approximately 0.6. I'm going to go ahead and do this to the thousandths, 696. So 285 is 0.696 power. Or the x value here is going to be 0.696 rather, is what that ends up being. All right, and then we're going to do the same thing here. So we've got this here expression. So you take the log base 10 of both sides. Now this will be a little bit more interesting, I think, is equal to the log base 10 of 144. So you notice a lot of the times our right-hand side isn't going to be all that interesting. Also back here, this should be the log of the left-hand side divided by the log of the right-hand side. Sorry, this should be right-hand side and left-hand side. All right, so now we can use our power rule. So we've got 2x plus 1 multiplied by the log of 25 is equal to log of 144. So it looks like this is going to be a little bit more complicated here. go ahead, and you guys shouldn't be running out of space like I am, but I'm going to go ahead and take this whole problem and I'm going to put it on the next page. All right, so now we can distribute the log of 25, right? So we have 2x log 25 plus log of 25 is equal to the log of 144. All right, so now we've distributed, and now we want to isolate x, right? So this is going to follow our regular PEMDAS rule. So I want to subtract this log of 25 from both sides. But we also know that that's going to affect our logarithms in a different way. So log 144 minus log of 25 is actually going to become the log of 144 divided by 25. So that's going to consolidate that logarithm. And then we have 2x times the log of 25 here. And then now this looks exactly like our other problem. So we can say x is equal to log of 144 divided by 25, all divided by 2 times the log of 25. And so we can get an approximate answer here. And so x is approximately equal to 0.272. So that'll be my approximate answer there. And that's about as good as you're going to get with a logarithm like this, is an approximate answer. All right, so armed with this knowledge, let's go ahead and start on 7-9, which is our practice for today. So there are 12 problems, and I do expect you guys to get all through 12 of them today. So that's your assignment, and additionally, I want you to reflect. Why do we need to know the method for solving equations of the same base? Why not use that second method all the time? And that's really just a number sense question, right? Why would we need to know the way to do it for the same bases? Why would that be important to us? Think about a situation where that might occur. All right, have a wonderful day, and let me know if you have any questions. Goodbye.